Here are the solutions for the worksheet entitled Molarity. Every question on this paper involves molarity in some way, except for question 1. Question 1 is about the concentration of a solution using a measurement called mass percent, or another way to say that is percent by mass. The questions for problem 1 use the following formula. Take the mass of the solute and divide by the mass of the entire solution. This ratio will output a decimal, which can be turned into a percent by multiplying by 100. Over here on the right side, let's do question A. It says that there's 2.0 grams of salt dissolved into 48 grams of water. The NaCl is the solute. The water is the solvent. The mixture that results from dissolving the solute within the solvent is called a solution. Question A, the mass of the solute is 2.0 grams. Now the mass of the solution. And notice the denominator is the mass of the solution, not the mass of the solvent. How heavy is the entire solution if you have 2 grams of salt and 48 grams of water? That would be 50 grams. On a calculator, 2 divided by 50 is 0.04, and you multiply by 100 to get the percent, 4%. This first solution is 4% sodium chloride. The rest of it, the other 96% of it, is water. All of the questions are done the same way. 6.0 grams of solute divided by 102.0 grams for the solution. This is the decimal point 058, which is the percent, 5.8%. Question C, 8.0 kilograms of solute and 56 kilograms of solution. On a calculator, 8 divided by 56 is 0.143, and that's 14.3%. Question D, you show out the work steps. Don't skip the work. And then when you want to check your answer, it's 0.02, which is 2%. When you turn this paper in, I'm going to check that you have done that work step and you haven't just copied my answer. Now question 3. This time, we're not asked to find the concentration of the sodium chloride solutions using percent by mass. We're asked to find the molarity. So all of the questions in this problem, we use the molarity formula. Molarity equals number of moles divided by liters. And that denominator has to be in liters. It can't be milliliters. So if you're given a number in milliliters, you divide by 1,000 to make liters. Here is question A, using the formula. The number of moles is 0.50 moles divided by the liters, 0.200. Divide these on a calculator, and the result is 2.5. The label is moles per liter, or even faster than that, you put a capital M, and it stands for molar. Question B, do the same formula. The number of moles divided by the number of liters. On a calculator, this makes 4.0 molar. Question C. There are 0.25 moles, and it says 100 milliliters. That's 0.100 liters. The other day in class, we discussed how you turn milliliters into liters. You divide by 1,000 to change to liters. On a calculator, this makes 2.5 molar. Finally, question D. Follow that same formula. I'm not going to show the workout, but when you check your answer, you need to get 2.5 molar. Make sure you show that work if you want full points on this. Next, number 5. The question is, how many moles of solute are used in these solutions? And what we're given about the solutions is we're given the volume. In 3 cases, the volume is in liters. 1 time it's in milliliters. And the other thing we're given is the molarity. Here is question A. Use the molarity formula because it relates molarity, number of moles, and liters. Make substitutions. In place of capital M is this value right here. That is the molarity. So 0.550. The letter N we don't know. The number of liters is 10.0. And now you solve this equation with your algebra skills. Multiply both sides by the 10.0 because that causes this to cancel out, leaving the letter N alone. On a calculator, 0.550 times 10 is 5.50. The label is moles. Question B, same formula. The molarity is 12. The number of moles is unknown. The liters is 5.0. To get N alone, you multiply by the 5.0. 12 times 5 is 60. And the label is moles. Question C, same formula. The molarity is 19.4. The number of moles is unknown. The liters is 250. To solve for N, you multiply by 250. I'm not going to put in the answer. Make sure you do so. Take your calculator and multiply these two numbers together to get the result and include the proper label. Question D, same formula. Fill in the numbers. And to check if you're right, the result is 2.13 moles. For full credit, make sure you have shown the substitution work. Next, number 7. Calculate the new molarity that results when each of the following solutions is diluted with water to a final total volume of 1.00 liters. This is a dilution problem, so all of the questions are going to use this math formula. When it asks us to find the new molarity, that's the M2. When it says the final total volume is 1.00 liters, that's volume 2, the volume that we want to prepare by diluting something with water. Now looking at A, B, C, and D, all of that information is the M1 and the V1. Now there's something I notice. In this question, our volume number 2 has the label liters. But in A, B, and D, the volume is in milliliters. We want to make sure our volume is using the same units every time. So we have two options. We can leave V2 as 1.00 liters and then change all of the milliliters into liters. Like the 125 milliliters, that's 0.125 liters. Or in question B, this is 0.275 liters. Question D, this is 0.015 liters. Our other option is we could have changed volume 2 into milliliters, and then in question C, we could have turned the liters into milliliters. I'm going to use liters because that's what I've written on the screen so far. So over here on the side, here comes the answers. Start with the formula and make the substitutions. M1 is 0.105. Volume number 1 is 0.125 liters. M2 is our unknown, and volume number 2, the amount of solution we want to prepare, is 1.00 liters. To solve for M2, we divide both sides by 1.00. The reason for that is this cancels out, and the M2 is now alone. On a calculator, multiply together these two numbers and then divide by 1.00. The result is 0.0131 molar. Question B. Use the same formula and fill in the numbers. M1 is 0.500. V1 is 0.275 liters. M2 is our unknown, and V2 is 1.00 liters. On the calculator, multiply together the two numbers on the left side and then divide by the 1.00. The result is 0.375 molar. Question C. Fill the numbers into the formula. Molarity number 1 is 0.750. Volume number 1 is 0.500 liters. M2 is unknown, and volume number 2 is 1.00. Multiply together the two numbers on the left side and then divide by 1.00 to get this answer. Make sure you type that in and you write an answer down to get full credit. Question D. All right, I'm not going to show out the substitutions. You think about that based on the pattern that you see. To check that your answer is correct, you're hoping you get 0.27 molar on your calculator. Question 15. To what volume must 100 milliliters of 1.0 molar sodium chloride be diluted in order to obtain a 0.1 molar solution? This is a dilution problem. The formula is M1 V1 equals M2 V2. What are we beginning with? And then we add water to it to dilute it. We're starting with 100 milliliters. That's volume 1. This is the concentration of that original solution, M1. Now we're diluting it in order to obtain or to prepare a new solution. This is the molarity of the new solution. What we're asked is, what is the volume of the new solution? That's V2. Make the substitutions. 1.0, 100, and then on the other side, 0.10 and V2. To solve for V2, you divide both sides by the 0.10. Then that crosses out and the V2 is alone. On a calculator, multiply together the two numbers in black ink and then divide by the purple number. The result is 1,000. Capital V is volume. In the problem, volume was in milliliters this time. Remember, sometimes volume is in liters, but sometimes it's in milliliters. This problem, it is in milliliters. Question 16. How many liters of 0.5 molar solution can be produced from 0.5 liters of 3.0 molar solution? We're starting with one solution and creating another less concentrated solution. This is a dilution problem. Here's the formula. What are we starting with? Here's your keyword, from. So this is volume 1, this is molarity 1. Over here, this is molarity 2, and it asks us how many liters, that's volume 2. Now come the substitutions. 3.0, 0.50, 0.50, and then volume 2. One way to do it is to multiply the numbers on the left side and then divide by the 0.50. Another thing you might notice is both sides have a 0.50. So I guess the V2 has to be 3.0, just like how on the left side there's the 3.0. This time volume is in liters. And the last one, number 18. If 200 milliliters of a 0.25 molar solution is mixed with enough solvent to make 1,000 milliliters of final solution, what is the concentration of this diluted solution? It's going to be the same formula. What's the stuff we're starting with? 200 milliliters, volume 1. 0.25 molar, molarity 1. What happens? We mix in more water and we make a new solution. This is volume 2, and the question is, what is the concentration of the new solution? That's M2. Please fill all the numbers into the positions. Don't skip that part. And then when you check the answer that your calculator gives you, if you want to know if you're correct, you're hoping to get 0.05 molar. This concludes the solution guide to the worksheet.